Hello everyone, in this video we are going to discuss the first machine learning algorithm, that is linear regression. Okay, so basically, if you guys remember, within supervised learning there are two kinds of algorithms. One is regression algorithms and the other one is classification algorithms. So what kind of problems will come under regression algorithms? Regression algorithms or regression problems are the problems which are having output as continuous. Okay, so if the output is continuous, we call that as regression problem. If the output is discrete, then we call it as classification problem. Okay, so like this linear regression algorithm is used to solve regression kind of problems. Okay, so linear regression is used to solve regression kind of problems. So let's try to take one simple example of some regression problem and let's see how to approach for this linear regression. Okay, so let's take a simple example of price prediction. So if you guys remember the first step of some machine learning process, first step in the machine learning process, what is that? That is data collection, right? So let's suppose we are not having any kind of data that is available on some websites. So then how will we think? So we'll be taking our output, that is price. Okay. So we have to collect the data. Let's see how to collect the data. So in data collection part, the price will be our output. So like we'll be having several names. One is output, or we can call it as label, or we can call it as dependent variable. Like that, we are having several names for the output, or we can also call it as output feature. Like that, there are several names for this. And similarly, we need to think of what are all the features or the inputs that are like used in order to predict the output, that is price. So if we want to, like if we started thinking, then we feel that area will be some good input so that we can predict the price, and also number of bedrooms can be one good input, and similarly number of bathrooms can be one good input. And similarly, if we think of latitude will be one good input, and longitude. Combinedly, these two will give us what is the exact location of that particular flat. So location is a good feature, right? So location we can denote with these two. Like that, we can have several features. Okay. So these are all called as input features. Okay. All the inputs that we will be taking, all those are called as input features, or we can also call them as independent variables. So these are all the names for inputs. Okay. So like we'll be having some like these will be our input features and this is the output, that is price. So with the help of input values like A1, let's say B1, C1, D1, E1, these are the values of area, bedroom, bathroom, latitude, and longitude. And for all the features, we'll be having some specific values. And finally, we'll be having some output corresponding to these input values. And that is our output Y1. So like that, we need to collect the data. Okay. So this is called as one data point. Like that, we need to have several data points, A1, A2, B2. These are the corresponding area value and corresponding number of bedrooms, corresponding number of bathrooms, corresponding latitude value for that particular flat. Like that, all these informations will be stored. And finally, corresponding to all these things, what is the actual price that we'll be storing over here? Like that, we'll be having some multiple points. Let's say, for suppose we are having n points. Okay. A and B and C and D and E and like that. If we are having endpoints corresponding to it, they will be having an output. And so this whole thing we call it as our data set. Okay. So this is called as our data set. So with the help of this data set, we'll be training our model. In general, the data that we show it to the model, that we call it as training data set. Okay. So like if we are showing this whole data to our model, then we say this as our training data. Okay. So I hope these terms are clear for you. Okay. So we can call these as output, label, dependent variables, or output features. And similarly, we can call inputs as input features, independent variables. Like that, several notations will be there. Sometimes I'll be using one of those, so don't confuse with that. And also, we'll be having data like this initially. That whole uh, like we'll be storing in these in some CSV files. So that whole thing we can call it as data set. And if you are showing that whole data set to the model, then we call it as training data set. Okay. So for simplicity, like in order to understand linear regression, initially let's only consider only one feature. We'll see or we'll extend it to multiple features. For now, let's only consider one feature, that is area. Okay. So with respect to area, let's predict the output, that is price. So this is our label and this is our input feature. So based on this feature, we wanted to predict the output, that is price. And there will be several values, A1, Y1, A2, Y2, like that. For each and every value of area, we'll be having some corresponding output, that is these things that are represented over here. So let's try to observe the same with the help of the graph. So if we try to plot these points on some graph, so on our axis, let's take the price. So let's say this axis represents our price and this axis represents our area. And if we try to plot all these points, that means let's say here it is A1 and here it is Y1. So on intersection of these two, we are plotting the point A1, Y1. Similarly, if we plot all these points, then these points might look like this. So in general, with increase in area, the price will increase, right? So the points will look like this, but they are not exactly increasing. There will be some deviations like this. That might be due to various reasons. Okay, so as we are only considering area, like the price might be differing due to the location or like what are the facilities it is having. Due to that, the real world data will have little deviations. But overall, if you observe, with increase in area, like area will be increasing in this axis or like this, it will increase. So with increase in area, the price is also increasing. So that we can clearly observe from this particular graph. The model needs to observe the pattern and has to find for some new data point. Let's say, like after training the model, if you are giving new data point, that is AI. Okay. So for this AI, we need to predict some value or we need to predict price corresponding to it. So we need to predict Y. Okay. So like if we are given such thing or if humans are given such thing, how will human find out the answer? So just think of it for some time. So like if I'm given some AI and also I'm having some previous data, then what I'll do, most probably by observing the previous data, I'll think that like for this area, this might be the price, like that. I'll be getting some understanding, right? So if someone draws some graph like this and ask me how can I predict for some new point, then most probably I'll be thinking like as the data is linear, I might find some relation like this, like some straight line. And for this point, I'll try to see where it is touching this line, and corresponding price will be the output. Like that, like I'll be thinking of some approach in order to predict the price based on the given data. And similarly, the model also has to do the same, right? So model also has to behave like human. That is only AI. So AI is mimicking human behavior. Here, from our intelligence, we are thinking that as the data is linear. So here, linear means that if it's following some straight line kind of pattern, then we call it as linear. Okay. So this is the kind of linear data, and for such linear data, it's better to use some straight line. That is the intuition as a human that we are getting. Now let's try to make the model or tell the model like to do the same. So for the model, it has to do by itself, right? So we'll just initially tell the model to draw some line. Okay. So what we'll do, we'll ask the model to draw a line. So what the model will do, like this is the price and this is the area, and we are having data points like this. So these are the data points that we are having. For these data points, we are thinking of some line and we are saying this is the best line. As human, we will think that like if we wanted to draw some line, we'll draw like this only. Why we'll draw like this? Because in our brain, we'll think that this is nearest to most of the points. That's why we are drawing like this, right? So this will be some optimal line because it is near to most of the points. Okay. If human is asked to draw some line, he'll most probably draw like this. But when we are telling the machine to do the same, the machine can't exactly draw like this. Why is that? Because the machine doesn't know anything, right? Whenever we ask it to draw some line, the machine can randomly draw the line like this. Okay. So after drawing this line, we need to tell the machine that whatever line you have drawn is not correct. Okay. So that we need to tell. So first of all, as I said, we are saying the machine to draw some line, right? So this is our hypothesis. So whatever we tell initially to the model, that is simply our hypothesis. And here, what is our hypothesis in case of linear regression? We are asking the model to draw some line. And initially, it might draw some line like this. And after drawing this line, what we need to do, we need to tell the machine, or the machine needs to know that whatever line it has drawn is wrong. So in order to tell that line is wrong, they will use something called as loss function. So this loss function will signify how bad the hypothesis is. So how can we tell that this line is bad? That we can tell by observing the difference between the actual and predicted prices. Okay. So here if you observe, this is our actual price for this particular data point or for this particular area. This is the actual price. And for this, what is our predicted price? So here it is touching. So here we'll be having the predicted price. So this is our predicted price. So like simplest loss, we can denote it with actual minus predicted value. Okay. As we are denoting our output with y actual minus y predicted. Okay. So this will be our loss function simply. With the use of this particular loss function, we can get, or we can understand that it will sum up on all the data points that we are having, and we can do some kind of average on this. Okay. So on doing this kind of average, we'll get to know what is the overall error that is shown by this particular hypothesis. And based on that, we need to update this particular line. So as the loss is very high, the model will try to update this line with the help of optimizer. So we'll be having optimizer. So with the help of optimizer, the model will try to adjust this line. So how will it will be adjusting? It will try to adjust like this initially. So on adjusting like this, will the loss reduce or increase? The loss will reduce because it is coming near to this, right? And also this side also it is coming near to these points. And even though like we are changing a bit, even then the line is not, even then it is having a lot of error. So it will try to adjust it again like this. And now also there is some error. Then it will slowly like move towards the optimal and finally reach the optimal at some point of time. And then we'll be stopping. So this is the overall process that is happening in this linear regression process. So let's try to see what are all these three steps that we have discussed. First one is hypothesis. Hypothesis is like telling the machine learning model what to do. Okay. And after hypothesis, we are having something like loss function. So we have told the machine that you have to do this particular line. In case of linear regression, we are asking the model to draw some straight line. And the line that is drawn by the linear regression algorithm might not be good. So to signify that, we are using this particular loss function, and this loss function will tell the model that whatever line that you have drawn is really bad. Okay. And after telling that, the model has to adjust, right? So that it will be doing with the help of some optimizer algorithm. Okay. So these are the three steps involved in any of the machine learning algorithm, not only in this, but these steps might change a little. Okay. So that is about hypothesis, loss function, and optimizer. I hope this theory part is clear for everyone. Okay. So if it's clear, then thank you everyone. See you in the next video.